So here's a really nice geometric question that can be solved using coordinate geometry. Part A says we want to find the midpoints P, Q, R, S of the sides A, B, B, C, C, D, and D, A. So these are this point, P, Q, R, S. And that should be pretty easy to do. P is going to be the point A1 plus B1 over 2, A2 plus B2 over 2. Q is going to be the point B1 plus C1 over 2, B2 plus C2 over 2. You kind of get the point. I'm not going to do all of them. Then, find the midpoints of the diagonals PR and QS. So here's PR, and here is QS, and we want to find the midpoints. Now, I might have to just quickly do R. That is going to be C1 plus D1 over 2, C2 plus D2 over 2, and S is going to be D1 plus A1 over 2, D2 plus A2 over 2. Okay, didn't want to do all of them, but anyway. So, midpoint of PR, okay, is going to be A1 plus B1 over 2 plus C1 plus D1 over 2 over 2, comma, A2 plus B2 over 2 plus C2 plus D2 over 2 over 2. Now, these are the same denominator, so we can just turn it into a single fraction. And we've got a double fraction scenario here. So this turns into A1 plus B1 plus C1 plus D1 over 4, A2 plus B2 plus C2 plus D2 over 4. Because if you divide by 2 and divide by 2 again, you're going to be dividing by 4. So that's the first midpoint of PR. So I'll just write midpoint of PR. The funny thing is, if you work out the midpoint of QS, you're going to find it's the same. QS is going to be B1 plus C1 over 2 plus D1 plus A1 over 2 over 2, which just turns into A1 plus B1 plus C1 plus D1 over 4, just in a different order. So we see that the midpoints of the diagonals PR and QS are actually going to be the same. Now, that leads us to part C. Explain why this proves PQRS is a parallelogram. This is one of the properties of a parallelogram. Okay, very important and useful property. And that is the diagonals of a parallelogram will bisect each other. In other words, the midpoints are going to be the same. And that pretty much solves our problem and shows that we can solve a lot of nice geometry problems using our friend coordinate geometry. Thank you.